I'm going to talk a little bit about the project for this module, which is a project about wind chill. And it's a useful way to learn how to convert a mathematical formula into program code. And this is something that you might be asked to do often as a programmer. So I always end up talking about this in the summer, and I know it's 90 degrees probably wherever you are. And so you need to imagine, for purposes of this project, that it's winter and you're in, say, Canada, where maybe it's like 30 below. So the effect of that temperature, like that 30 below, on the human body, on your skin, depends partly on the wind speed. The higher the wind speed, the colder it feels. Now, we don't experience that a lot here in Florida, but it's a very marked effect in northern climates. This effect can be calculated. You can predict if the wind speed is a certain speed V and the temperature is a certain temperature T, how cold that will feel in your skin. And that's called a wind chill. So that's the formula we're going to use for our project here. We're going to use that formula to learn about variables, which you need in your program, and constants, which are the numbers you have in your program, and various mathematical operators and methods in processing. Now, the imposing looking formula given here, which you probably can't read on the video, but you certainly can read on the web page that's linked in the project, this is what we're going to translate. This is how wind chill is calculated, and it looks pretty scary. It's got a bunch of numbers in it. It's got some implicit operators we're going to have to find. It's got some strange notation, because math has a very rich notation, and there's lots of different ways to write the same expression in math. And of course, when we translate that into processing code, there's really only one way to write it in code, and we're going to learn how to write the code based on what the math says. However, what you need to remember is, and maybe some of you are already concerned here, it's not necessary to understand any higher math, no calculus, very little algebra, no trigonometry, to solve this equation, to use this equation, because we're not trying to solve it. We're not trying to derive it. We're not trying to rearrange it algebraically. We're just trying to convert the expression as written into processing code. And that's a much more straightforward thing to do. It's useful to understand a little bit about arithmetic and what you obviously have to know what adding, subtracting, multiplying, dividing is, but you don't have to know any advanced math whatsoever to successfully complete this project. In the next video, we'll talk a little more about how to begin translating this into code.